Okay, so in this lesson, we're going to look at writing equations of a circle with certain conditions. And the conditions in this case is that the circle will be tangent to a line. So we need to talk about what we mean by the word tangent. You've never heard that word probably with regards to a, a graph being tangent to a line. So this is what we mean. This is what we mean by tangent. So a line is tangent to a graph means that it touches or intersects the graph at one point. Okay, at one point. So for example, now listen carefully to these scenarios. We are looking at a circle. So I am just going to be looking at circles here. If I draw a line here, and I'm going to use a thicker pen, but if I draw a line like this, okay, that line right here is not a tangent line. So this is not a tangent line. And the reason that this circle is not tangent to the line is because it intersects it at two places, here and here. All right. So remember the definition says it's got to touch or intersect at one point. So notice that this is not a tangent line since it intersects twice. Since the line intersects the circle twice. Okay? Now in future courses you're going to learn that this is called a secant line. So this is a secant line. This is a secant line. Okay. Now, a tangent line is this. Now, look carefully. Listen carefully. So this would be a tangent line. So, for example, if I were to just look at one point, see, let's say this point right here on this circle, okay? That point right here. And if I take my ruler and I put it in such a way and I draw the line, you're going to notice something. See this right here? This right here is a tangent line because it only touched the circle at this point right here. That's a tangent line. So this right here is a tangent line. You understand what I mean by tangent line now, right? So how many tangent lines does this circle have? Well, this circle has an infinite number of tangent lines. You can draw any point. Remember, there's an infinite number of points on a circle, right? So you can draw any point on the circle and draw a line tangent to it. Any point on the circle and draw a line tangent to it. So for example, see this point right here? I can take my ruler and very carefully draw this line to where it only touches the circle at that point. So there's an infinite number of these tangent lines. Okay, so that's something important. Oops, let me redo this. So that's something important you need to know, that a circle has an infinite number of tangent lines. Okay? Now, here's the situation. And we got to look at this idea. So, if I draw this tangent line right here, okay, now look carefully. So I'm going to draw a vertical tangent line right here. You see this point right here? Okay? And I'm going to, oh, and by the way, this point right here, what are the coordinates of that point? So it's not labeled, but we can label this. Here's the y-axis, here's the x-axis, so this is the origin right here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So the x-coordinate's 9. And the y-coordinate is 1, 2, 3. So 9, 3. Because the center's at 4, 3, so this has to be 3, right? Okay, so if I draw a vertical line right here, okay, do y'all agree that this line I just drew is a tangent line to the circle? But what kind of tangent line is this? This is a vertical tangent line. This is a vertical tangent line. What's the equation of that tangent line? We talked about writing equations of vertical lines before. So the equation of that vertical line is x equal 9, right? X equal 9. Okay? What if I had this? What if I had this tangent line right here? All right. So the coordinates of that point are, let's see, 1, 2, 3, 4, comma, and then negative 2. Okay, 1, 2. All right. So if I draw this horizontal tangent line, okay, this horizontal tangent line, remember this is a horizontal tangent line right here. What's the equation of a horizontal line? It's y equals, and so what's the y coordinate at every point on this horizontal line? The y coordinate is -2. So it's y equal -2. Okay? All right, so one of the things that we're going to look at in a few minutes is that you're going to have a circle that's tangent to either a vertical line or a horizontal line. So we had to review a couple of things here. So we had to review how to write the equation of a vertical line and a horizontal line. All right, so if I draw a line tangent to this point right here, is that going to be a horizontal or vertical line? Is the tangent horizontal or vertical? It is horizontal, right? So you're not going to do this because that's no longer a tangent. That's going to be a secant. So you want to draw a tangent. So the line tangent to this point is horizontal. And so I want you to notice something here. So that's a horizontal line, right? Okay, and the equation here would be y equal, and then that's what? 1, 2, 3, 4, 5, 6, 7, 8. Y equal 8. I want you to notice that. See where the center is? Where the center? So if you look at the horizontal diagonal and the vertical diagonal. So the horizontal diagonal at that point here, that's going to be a vertical tangent. This point here is going to be a vertical tangent from the center going straight up. This point here is you're going to have a horizontal tangent, and the same thing here. Okay? So we're going to use those ideas in a little while. All right, now let's look at this now. Listen carefully to the situations we have. So in number 1, so basically what you're going to do is this. So you want to find the standard form of the equation of a circle with the given conditions. And notice they have all the word tangents in all these 4 problems. So you're told that the center is at -7, 4. So sometimes it helps if you look at the diagram of this. So let's do that. So the center is at -7, 4, right? Okay. So the center is at -7, 4. So -7, 4, right here. There's the center. You are told that this circle, whatever the circle is, though, you're not told anything about the radius. You just told this. You're told that whatever your circle is, it's tangent to the x-axis. It's tangent to the x-axis. Okay, so this is number 1. So here's the x-axis, right? And so if it's tangent to the x-axis, and the x-axis is horizontal, correct? The x-axis is horizontal. And so remember when we talked about horizontal tangent lines, the point where those horizontal tangent lines are is right below and right above the center. Okay? So if I look at the center right here, and this circle is tangent to the x-axis, then that means that it's going to touch the tangent lines, the x-axis is going to touch the circle at this point only. So then I get something that looks like this. All right, so there's that circle, and I'm doing a very bad job drawing that circle, but the point being is this. I want you to notice that the circle will touch the x-axis at this point right here. Okay? And so here's the center. Remember, you're told the center is -7, 4, right? -7, 4. All right, now listen carefully. 2. Write the equation of a circle in standard form. So let's kind of review what we mean by standard form. Okay, standard form. All right, standard form. So standard form means this. So standard form means x minus h squared plus y minus k squared equals r squared. That's standard form. And in standard form, hk is your center and r is your radius. Now look how simple this problem is now. Okay, so this is number 1. What is the center in number 1? Well, the center is negative 7, 4, right? Okay. In the problem, were you told anything about the length of the radius? No. But we knew that this circle with this center was tangent to the x-axis. So if I look at this, and let's go back to the previous problem right here. Do y'all agree that the length of this, right here from here to here, that's a radius, and there's an infinite number of radii, right? That's a radius, that's a radius, that's a radius, that's a radius. What's the length of all these radii? From the center to any of these points right here. You just count 1, 2, 3, 4, 5. You don't even have to use the distance formula at all because the point here lies in a nice grid area. So you see where those are integers? So you can easily count the number of units. 1, 2, 3, 4, 5. That's the length of the radius. 1, 2, 3, 4, 5. That's the length of the radius. So using that idea here, you can do the same thing. What's the length of this radius right here? Right here. 1, 2, 3, 4. 4 units, right? And you remember in a vertical, you have a vertical length here, so you can just subtract the y coordinates. So remember, this is negative 7, 0. So 4 minus 0 is 4. So 1, 2, 3, 4. So that's the length of the radius. So the radius, the length of the radius is equals 4. So your radius is 4. And you just plug in. So we get x minus a negative 7 squared. Remember, x minus h, so this is your h, this is your k, plus y minus 4 squared equals the radius squared, right? Okay, now I do expect you to go ahead and rewrite this in a better way. So you got to remember, don't leave it as x minus a negative 7. You got to say x plus 7. And this is y minus 4 squared, and then 4 squared, you got to say 16. Don't say 4 squared, say 16. And so there's your answer. All right, so that's the equation of the circle. So that's the equation of the circle with center negative 7, 4 and tangent to the x-axis. All right, okay, so that was number 1. All right, let's look at number 2. So we're going to do that same idea. We're going to draw it. It helps if you draw it. It really does. So let's look at number 2. So number 2, you're told this. You're told that the center now is at 4, negative 2, and it's tangent to the line y equal 5, right? Okay, so let's plot the center first. So the center is 4, negative 2. So 4, negative 2, right here. So that's the center. 4, negative 2. And it's tangent to the line y equal 5. Well, remember, y equal 5 is a horizontal line. So let's draw this horizontal line. So if I draw y equal 5, that's this right here. All right, so that's this right here. So that's the, let me make it a little bit darker. So that's this right here, y equal 5. All right, so that's the line y equal 5. And so this circle, whatever the circle is, it's tangent to that line. Well, remember from our previous discussion, then in order for the circle to be tangent to that line, it's got to touch, see, here's the center, you go straight up. It's got to touch it at this point here. So that means that your circle looks something like this. Okay? So whatever, and again, I'm doing a very bad job drawing this circle, but it looks something like this. So again, in order to find the standard form of the equation of a circle, I need to know the center, and I do. and I need to know the length of the radius, and I know the length of the radius now, right here, right? So this right here is remember there's an infinite number of radii, but I'm going to use this one. So all I got to do is count the units. 1, 2, 3, 4, 5, 6, 7. So the length of the radius is 7. Now I also could have done this. So remember the coordinates here is 4, 5, right? And all you do to find the length of the vertical segment is to subtract the y coordinates. Subtract the y coordinates, and don't forget to take the absolute value. So in other words, you could say, all right, and it doesn't matter in which order you subtract the y coordinates. So someone could say, I'm going to start with -2. Okay, that's fine. And then you can subtract 5. So -2 and a -5 is a -7. So you see that's why we use absolute value, because the distance is always what? Positive. Okay? All right, so we now know the center. We knew that it was tangent to this line, which means that the point of tangency, this is called the point of tangency, by the way. Point of tangency. So the point of tangency is here, and then it's very easy to determine the length of the radius. So in number 2, we know the center. The center is -4, 2. And we know that the radius has length 7. So let's just substitute into our formula. So x minus, remember this is hk, x minus 4 squared plus y minus a -2 squared equals the radius squared, right? Okay, now rewrite this. I'm going to get x minus 4 squared plus y plus 2 squared equals 49. So that's the equation of this circle. With center for -2 and tangent to the line y equal 5. All right, let's look at so that was number 2. All right, let's look at the next one. So the next one is number 3, and it says this. So your center now is at -6, -2, and it's tangent to the line x equal -8. So remember, the line y equal 5 was horizontal. What about the line x equal -8? What kind of line is that? That is vertical. Okay, so let's look at a picture of this one. All right, so number 3, you're told the center is -6, -2, so that's here, -6, -2. Okay, and it is tangent to the line x equal -8. So x equal -8 is a vertical line, right? So it's a vertical line. And so let me go ahead and graph that vertical line. So here's x equal -8 right here. Okay, and so again, this is the line x equal -8. You're told that the circle, which has this center, -6, -2, make sure it is -6, yeah, -6, -2, and it's tangent to this vertical line. So that means that the point of tangency, remember, point of tangency is going to be here. So it's going to be that horizontal ray right here. So this is your point of tangency. Okay? And so the coordinates of this point of tangency is -8, -2. -8, -2. So if I draw this circle, it looks something like this. All right, so that will be the circle. Okay, so we're almost done with this. So we know the center. So I'm going to go back to this now. So this is number 3. We'll put number 3 here. So number 3, we know the center. The center is -6, -2. And the radius, the length of the radius is, you just count the units. 1, 2, right? Radius is 2. Oops, sorry. Radius is 2. Now you could also done this. You could also said, to find the length of the radius, you're going to subtract, remember this is horizontal, correct? So you're going to subtract, remember it's horizontal, you're going to subtract the x coordinates. So you're going to say negative 8 subtract negative 6. So, and don't forget to take absolute value. So negative 8 subtract negative 6, absolute value. Because remember the radius, distance is always going to be positive, so you need absolute value. And when I do that, I get negative 8 plus 6, correct? Which becomes absolute value of negative 2, which becomes 2. Okay, so that's another way you could have done that, just using the idea of subtracting either x coordinates or the y coordinates, whether it's horizontal or vertical. But these are nice numbers here. They're integers, so you can easily count off the number of units. So therefore, we get this. Here's hk, so we get x minus a negative 6 squared plus y minus a negative 2 squared equal the radius squared. Go further with this, so you're going to say x plus 6 squared plus y plus 2 squared equal 4. And so there's your answer. Okay? All right, let's look at number 4. So number 4, we have this. Okay, so we have this in number 4. You're told that the center is at 8, 5, and it's tangent to the y-axis. All right, so the center is at 8, 5, and tangent to the y-axis. So let's look at a diagram of this. It does help. It really does help if you look at this visually. So 8, 5 is in the first quadrant. So there's where 8, 5 is. Okay, so that's the center, 8, 5. So right away we know the center, right? So number 4, we know the center right away. Center's 8, 5. You just have to find the length of the radius. That's what you got to find. Well, here's what you're told. You're told that the circle that has this center right here is tangent to the y-axis. Well, the y-axis is this, right? So let's look at it. So I'm going to draw the tangent line, which is the y-axis. I'm going to go ahead and darken it like this. Okay, so that's the y-axis. And remember the equation here, if you remember, this is a vertical line, right? The y-axis is a vertical line. The equation of vertical line is x equal. What are the x coordinates when you're looking at any point on the y-axis? What are the x coordinates? Well, the x coordinates are 0, correct? So the equation of this y-axis is x equals 0. That confuses students because they want to say y equal. Remember, what the y-axis is vertical. So the equation of a vertical line is x equals some constant. And the constant here is 0. All right, so you're told that the y-axis is the tangent line, correct? So we got to figure out where's that point of tangency. Point of tangency to help us. Well, the point of tangency will be along either a horizontal line or a vertical line. But since this is a vertical tangency, we're going to go horizontally this way from the center. So this right here is going to be the point of tangency. Just go straight across, right? Just go to the right, to the left. Okay? So there's your point of tangency. So that means that my graph is going to look something like this. My circle, rather. Okay? Just like this. All right, I'm not doing a very good job drawing that circle. I'm not even going to finish this, but that's the idea that we need here. It's just this little part. Because now I know the radius, the length of the radius. What's the length of that radius right here? We'll just count the units. 1, so this from the center to the point of tangency. 1, 2, 3, 4, 5, 6, 7, 8. There's the length of the radius. You could have also gotten the length of the radius by not just by counting the number of units, but you know the point of tangency is 0, 5, right? 0, 5. Now don't say 5, 0. That confuses people too. 5 zeros on the x-axis. This is 0, 5. Okay, so to find the length of a horizontal segment, you're just going to subtract the x-coordinates. So just subtract the x-coordinates. And remember, absolute value is important because the distance must be positive. So it does not matter in the order in which you subtract x-coordinates because you're taking the absolute value of it anyway. So in other words, someone could have said this. Someone could have said, well, I can say the absolute value of 8 minus 0, right? which is the absolute value of 8, which is 8. That's true. Someone else could have said, well, I'm going to start with 0. Okay, no big deal. You can do that. 0 subtract this x coordinate. But now you see why the absolute value is needed, because if you didn't put absolute value, some of you would have said, well, the answer is -8, but no, it's not. Distance is going to be positive, so you must take the absolute value. And so that's why it's 8. So that's why when finding distances and when you derive like the distance formula, we use absolute value at some point. Okay, so then we have this now. We're almost done. So we know the length of the radius is 8. So I'm going to put right here, I'm going to put r is 8, and then I just substitute these values into our formula. So we get x minus 8 squared plus y minus, y minus 5 squared equal 8 squared, right? Okay, don't leave it like this. Some students leave it like this and they get pretty upset when they don't get full credit. We do expect you to know that 8 squared is 64, so go ahead and write a 64. So x minus 8 squared plus y minus 5 squared equal 64. And that's it. So now you know what tangent lines are and how to use them with circles. Okay, so that is the end of this lesson where we had to find the equation of a standard line, the equation of a circle in standard form with the word tangent. Okay, so that's the end of this lesson.